This topic is about the branched and the unbranched isomers. Isomers, as we know, are the molecules or compounds which have the same molecular formula but different structure. Okay, it has the same molecular formula but different structures. Let's take example of C4H10. From formula itself, you can figure out that it's an butane, it's an alkane. So the structure could be 4 carbon atoms and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen atoms. This is an unbranched isomer. Unbranched because all the atoms are in the straight line. Unbranched matlab there is no branching. It's a straight chain. Complete all the 4 carbon atoms are in a straight chain. If it's a branched, which means I have to take 3 carbon atoms in a chain and 4th carbon atom should be as a branch. Now allocate hydrogens to all of them. Now naming wise, there are 4 in the straight chain, so the name is but, and all single bonds, so in. Over here only 3 in the straight chain, so this is not but, and this is pro. And because single bond between them, so N. So propane is this part. But you haven't described this part in the name. So this part is a branch. Branch of 1 carbon atom, which means it's a methyl. Branch of 1 carbon atom, matlab, it's a methyl. And whenever you show the branch, whenever you mention the branch, always show the position of the branch. So this methyl branch is bonded to the carbon number 2 in this chain. So if you see the chain, carbon number 1, carbon number 2, carbon number 3. So this methyl branch is bonded to the carbon number 2. So I can say that 2-methyl propane. That is the name. To methyl propane. Now, if I take another molecule, C4H8, now the formula itself says that it's an alkene. So alkene may I have options like in the unbranched one, where I have to show all the 4 carbon atoms in a straight line, and because it's an alkene, I have to show a double bond. Now I have an option where to show the double bond. I can show the double bond between the first and second, or between the second and the third. These are 2 positions of double bond that I have. I will allocate the hydrogens accordingly. Now naming wise, this is a chain of 4, so but. This is also a chain of 4, so but. There is an alkene here, there is an alkene here also. But here the alkene is at carbon number 1, like carbon number 1, 2, 3, 4. And carbon number 1, 2, 3, 4. So this will be but 1 in because the double bond is at carbon number 1. This is but 2 in because the double bond is at carbon number 2. These 2 are the unbranched isomers because there is no branching here. Now, if I have to branch it, then I have to take only 3 carbons in a chain, and the double bond, which is in the is there in this, it has to be in the chain only, not in the branch. So branch will be here. Now the naming of this, before that we'll allocate the hydrogens. So the 8 hydrogens. Okay. Now again, this is the propene. It's not a but. So you have to name this as propene. On the propene, carbon number 1, carbon number 2, carbon number 3. At carbon number 2, there is a methyl branch. Methyl branch is bonded to carbon number 2. So I'll have to mention the position of the branch and what is the branch. So at carbon number 2, there is methyl in propene. Now this one is a branched isomer. Okay, now since we are already talking about isomers, let us learn about the isomers in the carboxylic acid and the esters. Okay, because recently there are a few questions on that. So remember that carboxylic acids and esters can be isomers of each other. Okay, now how do you take the isomer, like how do you derive the isomers of the carboxylic acids and the esters? Let's say if I have a carboxylic acid with 4 carbon atoms. So obviously that is a butanoic acid. So butanoic acid may I will provide 1, 2, 3 and 4 carbons. 4th carbon पे functional group and other carbons will have hydrogens. Okay. Now that's butanoic acid. Now how do I make the ester out of it? I can make, I think, more than 2 or maybe 3 esters I can make out of it. How? I just shift this carbon atom from this side to this side here, replacing this H. If I do that, I'll get an ester. Okay, see, I'll have to start my structure from here. So my structure becomes this is O, and this side there will be CH3. Okay, now this is an ester. If I shift 2 of these here, then I have to start my structure with this. So I will start the structure here. And those 2 carbon atoms will come on this side. Okay. And finally, if I shift all the 3 carbon atoms from here to replacing this hydrogen, then I get H here. COO and 3 carbons this side. Okay. Now, if you check, all the 4 compounds have the same molecular formula. All the 4 compounds have 4 carbons, 8 hydrogens, and 2 oxygens. Okay, which means all of them are isomers. Now the naming. This one, because COOH hai, it's an acid, and there are 4 carbons in total here, so it's a butanoic acid. Now in this one, I have taken 1 carbon from here over here, replacing that hydrogen. So in this side there is only 1 carbon, which means that is methyl, and there are 3 carbons here. So propanoate, because this comes from propanoic acid, methyl propanoate. In the next one, there are 2 carbons here on the right hand side, that's the alkyl part. Always remember that in the ester, the COO is the function group of ester. The carbon chain over here is the first word, and the carbon chain over here, including this carbon, is the second word. The first word COO के साइड में there are 2 carbons here, मतलब this is ethyl. Similarly, O के there are 3 carbons, मतलब this is propyl. The first word comes from the right side of the oxygen, and the COO including Others, like there are two carbons, matlab ethanoate, and there's only one carbon, matlab methanoate. So ethyl, ethanoate and propyl, methanoate. Okay. Now you can also derive from the name actually. There are 4 carbons, matlab total there should be but, like 4 होना चाहिए. So this is but, 4 carbons. इसमें meth है मतलब 1 carbon, prop है मतलब 3 carbons. 1 plus 3 is equal to 4 carbons. Here eth 2 carbon, eth 2 carbon, 2 plus 2 4 carbons. Prop 3 carbons, meth 1 carbon, 3 plus 1 is 4 carbons. So overall altogether they all should have 4 carbons. So if it's an acid, then all the carbon atoms are at one side only. In the acid, all the carbon atoms are on the one side, like all in the one chain. ऐसा लगे तो there will be split. This oxygen will be the splitting part. Oxygen का इस side में कितना है, इस side में कितना है. इस side में 1 है methyl, इस side में 3 है propanoid. Oxygen, there are 2 here and 2 here. So ethyl, ethanoid. Oxygen here, this side 3 propyl, this side 1 methanoid. Okay, so I have given more than one point of view, more than one way in which you can decide the isomer, the name and the structure. If you want, you can repeatedly watch this video till you understand, or you can let me know if you didn't understand. Okay, then I can take up in the next class. Right? So that's about the isomers. Okay. And also in the alcohols also you can have isomers. Alcohols may the position of the OH can be different. That's how you can get the isomers in the alcohol. Okay, so I'll just quickly do it. Isomers in the alcohols. If there are 4 carbons, so one way I can have isomer is the position of the OH. So OH is in carbon number 1 and OH is in carbon number 2. This is butane 1 all, butane 2 all. But both of them are unbranched isomers. If you want a branch isomer, then first of all you need to form a branch. So 4 carbon atoms there. Make 1 carbon atom as a branch, 3 in the straight chain, and then you can add the OH anywhere. You can add the OH here, or add the OH to this carbon, or to this carbon. Okay, that's how you get the branched isomer.